This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a lot of prototypes to talk through. So my co-host, Alan Hall here, is going to kind of pick apart a bunch of these different designs, talk about some of the good things and the bad things. And but we'll start with some news. Airbus talking about hydrogen, Starlink, internet, potentially providing fast Wi-Fi to planes, which is something pretty interesting that I hadn't thought about. And then we'll get into some different concepts, a tri-wing jumbo jet, an electric seaplane, and a really interesting what's called a fluidic propulsion system on a flying car concept, as well as one that has the wings detach and fly home. So again, this will be kind of fun. But let's start with news. Alan, so Airbus has said that the hydrogen is probably not going to be widely used in planes before 2050. So 30 years off. Does that sound right to you?
Well, they're talking about larger aircraft like an A320, A350 kind of aircraft not being able to switch over to hydrogen. I think that's right. The shorter commuter type aircraft, maybe propeller-driven aircraft, will be an easier conversion. And it makes a lot of sense because there's a lot of short routes in Europe and also in the United States that could handle a hydrogen aircraft, but it's going to have to be specifically designed, and that's why Airbus is pushing it back a little bit. I think early on there was an impression like we're going to make an Airbus A350 with hydrogen. That's not where Airbus. I don't think that's where their intent was. I think eventually, yes. I mean, that they did put out some PR about that, right? I mean, we saw all the promotional things. But that didn't have a timeline. If they're talking about hydrogen aircraft, yeah, they can totally, they can ATR 72 or the Dash 8 Q400 turboprop aircraft would be relatively modifiable into a hydrogen configuration. But after that, when you talk about changing a turbofan engine to hydrogen and all the infrastructure involved in aircraft for the fuel system, that's just going to take a long time because there's so many pieces to it. Hydrogen's a very small molecule. It leaks everywhere, whereas liquid fuel doesn't do that same thing. So all the design elements change, and pressures and temperatures are all different. You're starting over. It's what Airbus is saying. It's like, look, guys, we want to start over. We can't do that overnight. We can't even do it in 10 years.
Yeah, so it sounds like they're going to want all these current planes that use turbofans to just run their course, essentially, and then, like you said, just start from scratch, like a whole different design. Or, I mean, do you see it being like a really wacky, very different looking, like futuristic looking, or is it just going to be an A320 that's still pretty normal looking that runs on hydrogen? Like, is there a reason that it has to be strange looking to be futuristic and use a different propulsion system? Because like all these renderings you see, like, so they always seem very science fiction-y, right? But does it have to be that way, or it might look the same in 2050?
I think the aircraft essentially is going to look the same, except that the fuselage may get longer because the initial concepts involve putting hydrogen storage tanks of some sort in the fuselage.
True. The storage is a big one. Mm-hmm.
Right. So the fuselage may get longer, which means the wingspan may get a little bit longer also to keep every aircraft sort of in balance. But that's it, because the wings will have no fuel in them, liquid fuel in them. So you'll completely redesign the way the wings would be because they just need to maintain their own structure. They don't have any fuel sloshing around on them, so the structure will change there too. Yeah, and it's gonna be a basic fundamental kind of Airbus 350 kind of look, I think, but just with the longer aft fuselage section and tail.
So moving on, Starlink, which is obviously Elon Musk's company with SpaceX, is talking about putting Starlink internet into airplanes in the upcoming future with potentially 100 megabyte per second download and 20 megabyte per second upload, which would be much faster than, I mean, Alan, you're a much more frequent in-flight internet user than I am. What do you guess that it is It's not great. It's not as bad as it used to be. It's certainly gotten better, right? But
Yeah.
I mean, what do you think they're competing with as far as upload download speed today?
The consensus is they're competing with what is in people's homes. So that's the expectation level is when you get an aircraft, you have the same speed internet as what you have at the house or at work. And it hasn't been that way. I fly Southwest a lot, and Global Eagle is the service provider there. And the internet speeds aren't super fast. Like you can't stream anything. You can't have huge downloads. You can't stream a YouTube video or watch Netflix live. But you can do pretty much everything else. You can send email. You can download some files. It's not like being at work, or it's not like being at your house. It's just not there. But for most situations, it's reasonably good. It's not even really annoying, honestly. I've never tried to do massive internet file sharing while on an airplane, but maybe somebody has. And I know if YouTube were offered or live video streams were offered, people would take it and would use it. It's just not there yet. But Dan, the issue with like Starlink and there's a couple others that are going on simultaneously is that you have this geometry problem. Right now, the way the situation is, the spacecraft are geosynchronous. That means they're in a fixed position with the Earth. They're always if you always look in the same spot in the sky, it's always there. So from the aircraft's perspective, when it's flying, it knows where it is for the most part, and it knows generally where to look. And so it just takes one antenna to focus on one spacecraft and just sort of lock in on that and hold it. That's relatively simple to do. When you put a lot of low Earth orbit spacecraft in, they're moving and spinning around the Earth. So if I look up in the sky, I can actually watch these spacecraft go overhead of me. Okay. So now I got a moving aircraft and I got a moving spacecraft, and I got to data link those two together. All right, that's doable. So you have an antenna that knows generally what the schedule is of spacecraft, I would assume, or it's out there just searching for one, and it finds one, it links into it. Okay, great. So you're downloading your YouTube video with this one spacecraft as it's moving relative to the airplane. Awesome. Well, at some point that spacecraft is going to go out of range, going to go over the horizon. You're going to lose it. So you got to get to the next spacecraft and connect with it. So in the interim, you got one of two choices. You stop with the first spacecraft, let it go, and look around and find the second spacecraft, which means your YouTube video will stop streaming in that time period between spacecraft 1 and spacecraft 2. That kind of sucks, right? People don't like internet that's kind of spotty, which it would be spotty like that. The other way to do it is have spacecraft 1 kind of get near its edge of coverage, and the antenna be able to see spacecraft 2 and link into it and connect with it before you lose spacecraft 1. That's the engineering issue. How do you connect?
Get the overlap.
Right. How do you connect with spacecraft 2 before you disconnect? That's the issue, right? So in terms of existing hardware today on that the antennas that sit on the airplanes, that hardware is not able to make what they call make before break. It can't make before break. If you have to add either more antennas, so you have two antennas looking in two different directions, which is doable, or you have to have an electronic antenna that can look at two different spacecraft or more simultaneously. There's your dilemma,
okay.
Right? From the engineering side, it gets a lot more complicated to keep track of all this moving stuff in the sky and lock into it when you're in this moving aircraft that's going up, down, left, right, all over the place and bouncing through turbulence to try to keep all this organized. There's your technical challenge. So can Starlink provide better data streams? Yes. Does it going to require more complex hardware on the aircraft? Oh, yeah. And the big drawback has been so far on the electronically steered antennas is that it takes a lot of power to do this, to do the electronic steering and all the processing stuff that has to happen. The antennas get hot, like really hot, and particularly if they're on the ground. It's not so bad if you're flying where it's like minus 70 degrees Fahrenheit out there in the sky. That's awesome. It's a big heat sink. It's sucking all the heat out. But if I'm in Dubai, I'm on the ground and it's 120 and I want to stream my YouTube video, that antenna is going to get really hot. It's going to get hot enough on a composite airplane like the A350 where it may damage the aircraft skin, the fuselage. And you're not going to do that, right? Because you may trash an airplane doing that or really damage it sufficiently. So there's a technology problem, which is we want to have higher data streams and we want to do this low Earth orbit thing on spacecraft, but we got to deal with all the heat. So either we have a heat issue and nicely smooth antennas, or you have two antennas looking in different directions. That's the choice. And right now, no one's made that choice yet. SpaceX has some, I think they have some Gulfstream airplanes out there with prototype antennas on them flying around to try to see how the system works. But ultimately, you got to certify it, and the heat issue is going to be a big problem.
That's such an interesting answer. I mean, I wouldn't expect anything less from you since you've worked with so many of these companies like Viasat and GoGo, on radomes, and your ins and outs here. But people think, oh yeah, let's just upgrade the internet, and they never think that it's so technical and that there might be other issues of damaging the actual airplane. Like that just, it's crazy how many of these aircraft issues are just way more complex than they seem like.
Right, and you've had a couple of companies start and stop on electronically steered antennas. There's no moving parts there. And that has not come to fruition. They've always had this heat problem they couldn't get over. FinCom, which is the antennas for GoGo, which look like sort of pizza plates that spin. So they are flat when they're round, and they steer, sort of, but they also spin, which is part of the steering thing. They've been talking about being able to make before break and maybe having two sets of antennas, but they're really low profile, and their efficiency is really good. And so ThinkCom's really found a sweet spot there. I'm not sure it's the ultimate final answer, but it's a pretty good answer for right now. And I think you may see like two sets of antennas installed, ThinkCom antennas, that would do the make before break and do all the LEO stuff. That may be the at least the interim solution, maybe the final solution if it works well.
All right, so in our engineering segment today, we're going to talk about this really fascinating prototype from SE Aeronautics that is a jumbo jet, the SE200. It's a super efficient subsonic jet. They say can carry 264 plus passengers at Mach 0.9 with a range of 10,560 miles. And one of the key features here is that it has 3 wings, and that is going to give them some sort of aerodynamic boost. Alan, there's been a bunch of really interesting concepts that we'll talk through here, many of which have come from robreport.com. So definitely check out their website. They seem to really enjoy all these, futuristic prototypes of planes, cars, buses, boats, all of it. But what's the advantage of having multiple wings, and why don't we see planes with multiple wings?
Because it doesn't work very well dynamically.
And why are they touting it? Well, and why are they saying it's the future?
I think there's a difference between sort of standardized flight and then what actually happens in flight and all the weird configurations an aircraft can get into and all the limitations and flight demonstrations that are put on an aircraft to show that it's safe to fly, that it stalls safely, that the pilot can control it into stall and out of stall, and all the other odd flight performance things that have to happen there. That's where you get back to these conventional designs, because they have shown effective means of complying with the regulations, be them FAA or EASA or Transport Canada. It doesn't really make any difference, right? So from an aerodynamic standpoint, it may work. Doesn't seem like it's going to work, but it may work. But there's so many variables in certifying an aircraft that unique designs kind of get tossed to the wayside because it's going to be so expensive to show that they work. And can you imagine building a full-scale prototype, a full-scale aircraft, and then going out to flight test it and go, oh man, we got a problem we can't get over?
Yeah, because if one wing, there's something like you can't just chop off a wing with a sawzall.
Yeah. Well, in the good old days,
right?
they used to do that. Actually, when I worked at Beach Aircraft back in the 90s, I guess, there's some really interesting discussions about how they made airplanes and how they modded airplanes at night. So they fly them during the daytime, and then they'd mod them at night, and they would literally cut off parts of like tails and stick on another tail, because a lot of times they're made out of wood. So yeah, I mean that day and time has gone by where you could cut off and lop off and reattach different parts of the aircraft. That doesn't happen very much anymore, particularly with composites and aluminums. This doesn't really happen all that much. Yeah, so you'd hate to be $500 million into it and realize you can't certify it. That's the wrong time to find that out.
Well, and you've said that many times. Can't certify it. Realize, find out you can't certify it. I mean, what does that mean? It just means that y'all get in a room and you realize that there's just a hurdle that, I mean, what does that actually look like when they say we can't certify this?
It doesn't happen very often today, but if you have an aircraft, you have a set of regulations, or performance regulations, a minimum performance. I always call them minimum performance standards. The FAA and EASA create minimum performance standards. The aircraft can work better than that, but at a minimum, it's going to do these things. And so what happens is, if you have, like, stall can be a big one, or zero-G pushovers, or some of those swept wing aircraft can have a problem in certain flight configurations where they want to deep stall and roll over. There are certain aerodynamic features about an airplane that, if not dealt with correctly, you can't certify it. So that's why you see, if you look at a new clean sheet aircraft design, and maybe that first flying prototype aircraft, and look at the wing, look how clean it is, and then look at what's certified at the end, usually there's a little bit of aerodynamic treatment, vortex generators, stall fences, boundary trip layer, things on the leading edge, where they couldn't certify it without adding on pieces. And that's what it means, is that you couldn't certify it. So they needed to add some adjustments to the aerodynamics. And you see that a lot from first prototype to the final design. But if you choose a very unique design, which has no proven data, you really didn't even know where to go. So if you got into a performance issue, a safety issue in terms of its flight performance, you're in this weird aerodynamic space where you don't have any history and you don't know what the little band-aids are to fix it. Right, and so you're into this big R&D effort late in the program. Now, a lot of aircraft, there's been a number of aircraft that have had issues structurally that sunk them in terms of pressurization cycles or certain ultimate loads that they don't handle. That can be very, very expensive to fix late in a program. I've been around a couple of those, and when you have an aircraft structure fail at a load that's less than what's required, that's a big deal, because at that point you probably have 10 aircraft on the line you've already manufactured, and you got to go back and fix the structure. That's expensive, and it's time delay, and that can pretty much sink a program if you don't have the cash to withstand it.
So it just sounds like it just is going to continue just to be little iterations on the designs you already have. And for something this big, I mean, this is a jumbo jet. So like you said, the idea of this thing being actually produced without having the real world data, whether it's going to be certifiable, is pretty scary.
It's scary, right? And that's what drives investors away. But we're seeing a lot of investment into eVTOLs. They have very unique designs today. But again, there's a big downside risk that you can't certify it. And you could be literally $1 billion or $2 billion into an aircraft program and realize we got to make big adjustments to it and quasi start over, or at least go back to the early stages. And that eats up so much cash that you just can't make it through it.
All right, so moving on to our eVTOL and really just electric segment today. There's a bunch of other prototypes that are just interesting, maybe the future, maybe difficult to come to fruition. First on the docket, this is also one we found on Rob Report, an all-electric seaplane the Regent Sea Glider, and it's going to fly at 180 miles per hour just above the water surface. I mean, looks like just like turboprops. But Alan, I mean, is there a huge market for seaplanes, and how common is this that planes are hovering close to the water?
Well, the Russians have done this, or Soviets have done this for a long time, going across some large bodies of water. Basically, you're sort of like this ground effect situation where there's a cushion of air real close to the surface. So you get the aircraft moving a little bit. You can kind of get it where that you're basically compressing the air down into the water, and it creates this little cushion of air. It's very similar to when you're landing like in a 737. You get close to the ground, you feel the aircraft kind of float. That's what they're working on. They're working on that float process.
I have felt that. Okay, interesting.
Right. So it's an aircraft that lives in that principle. So it's only a few feet off the surface, but you can move fairly fast, and you're not that far off the ground where there's a huge risk. I mean, if you lost thrust, the airplane would just settle into the water again. You just be a gentle landing, just like you do anyway. So from a complexity standpoint, it's not very complex. But you're really limited to where you're going to fly this thing, which is over water, right? So if you're going across from Long Island to Connecticut or something, you could do that. And if you're going from, I don't know, Gulf of Mexico, going from Texas to Florida or something, you could do that. It'd be a slower mode of transportation. But on shorter routes, like if you're going across Lake Michigan, it'd be totally possible. Just think of it like a quasi very fast boat. I mean, it's essentially it, except it's just riding on a cushion of air all the way across. So it's a neat concept. We haven't seen it used in the United States in forever. I think it was back in the 40s when the last time I remember there was some work like that. But there are active aircraft, which would be today's Russia, I believe, that is still working on that principle, that are kind of cargo aircraft that move things from place to place on that cushion of air. It's really interesting technology, but haven't seen it much used in the United States in a long time.
Well, and one other feature of the Sea Glider is that it also can go through the water on foils.
Very similar.
So it has these things that come down, and so it acts as it's like a water taxi, a ferry. So the company Regent's got $465 million in provisional orders. So it sounds like there's definitely some interest here, which that one's pretty cool.
Wait a minute, 465 million? Is that what you just said?
Mm-hmm.
Wow, okay. That's a lot of cash.
Commercial airline and ferry companies.
That's $500 million. If I did my math right.
The ferry market is alive and kicking. So
wow.
Yeah, I've never been in a seaplane, so I want to see this come to effect. I want to be in this seaplane. No, I've not.
Yeah, talk about air sickness and seasickness. It's both of those at the same time. So you better not have any sensitivity to motion sickness, because you will have it in that environment. Yeah.
So our next prototype here is it's called this Flexcraft, and it basically allows the wings of this sort of flying car to then take off and fly back to the airport or your home or whatever. So the plane connects the car to the wings, flies where it needs to go. When you're done, wings take off and go home. I mean, it sounds so silly, but it also is like pretty interesting and fun. I mean, do you see the Flexcraft coming to fruition? That also just seems incredibly complex.
It is complex. There has been other efforts. I think in the 1970s, there was a very similar concept where the wing would attach, and then you'd fly with it, and you could take the wing off, and then propulsion system off, and then drive it like a car. Terrafugia in the Boston area was the latest one, where they had it was like a little car, but it had wings that would pop out or expand into place, and you could fly this aircraft and then retract them and then drive it like a car. That's been the latest effort similar to that, but they had trouble financially. I think the company ended up being sold to a conglomerate in China, if I remember correctly. So there's been a lot of attempts at this. No one's really made it happen, but it'd be interesting if Tesla would get involved in something like that, right? Talk about taking the existing car battery electric propulsion and be able to slap on some wings and go fly. That sounds like something Elon Musk could be interested in doing.
And then a different flex mode where it can go down into his boring tunnel, so you can collect a toll there as well.
Right.
Yeah.
Yeah. he can toll you in the air.
Just goes everywhere, and then it just comes into turns into a seaplane too. But part of the vision is that you'd have like this neighborhood drive-through where, you know, you like drive your pods over there and then go over and like hook up to the wings, which is it's a really interesting idea, but a lot of infrastructure.
It needs Tesla cash. Yeah,
probably would have to come after the EVTOL thing.
Yes.
Yeah, I don't know. It seems even harder than the EVTOL thing that everyone's trying to do. It's very popular these days, these EVTOLs. And then this really interesting concept, the Jetoptera J2000 VTOL uses bladeless Dyson-style fans. So they call this like a fluidic propulsion system. Alan, have you ever heard this in an aircraft?
No.
So I looked up these Dyson fans a while ago because I was just curious of how they worked. It's just like, it looks like a big, ring, but it has lots of little tiny jets around the edge, and it shoots air through those. And if you shoot a big ring of air, it'll pull the other air in the center of it through with it. And apparently that is the concept here as well, where if you have thrust all in a ring, it's going to suck the air into the center of it as well. That seems really neat, but again, this seems right up that same alley of being difficult to certify, and I don't know, how do you find redundancy for all this? And
Right. I mean, the reliability of it has to be outstanding, particularly if in this particular case, you have a couple of these different fluidic propulsion systems. If one of them dies, what happens? So the reliability is super key here, and the efficiency of it. If it's not as efficient as some of these electric propeller systems, then why mess with it? And the electric propeller system is going to be pretty darn efficient. So it's going to be hard to beat that. And if adding complexity to it makes it less reliable, then it's just not going to go. It has to have either fewer moving parts, and it's hard to beat an electric motor with a propeller on it in terms of moving parts because there's just not a lot of moving pieces there. And the efficiency is very high. So it doesn't seem like it's a reality. I guess in a sense that you would eliminate the rotating chopping blades situation that exists on the eVTOLs right now. So it would be more approachable, if that's the proper term for it. Humans are afraid of dying all the time, and they don't like walking into rotating blades, and they want to stay away from it as much as possible. Even when flying, I still don't like flying in line with the propellers on a propeller-driven aircraft. I want to be either in front of them or behind them, because if they ever let loose, bad stuff's going to happen.
Probably a moot point if the plane's going down, but yeah, I get it.
But a lot of times on a twin-engine turboprop, if you lost one propeller, you could get home, and it has happened.
Okay.
But you just have to be you just don't want to be the poor soul who's sitting next to that propeller. That's not good.
Yeah, that'd be rough.
Yeah.
Jetoptera has received a contract from the U.S. Air Force, so they got two small business technology transfer contracts to characterize the noise of their fluidic propulsion system. So there's some interest in what it does. Could it be quieter? All that sort of stuff.
Stealthier.
So maybe there's a application for it somewhere. I mean, it seems like the Air Force is always kind of gobbling up and just giving some money to these companies that have pretty outside the box things. And I don't know, maybe the Air Force has an idea for it, like something. I mean, especially with drones, like maybe something like this would be easily applied to drones,
right? And
be really quiet or something. Like they've got they could have a whole different idea rather than a flying car or air taxi concept. But
sure,
I'm all for it. I mean, the Dyson thing is super cool. I don't own one. I want to own one, but I think part of the allure of fans is that they make the noise, right? It's not just about cooling you off. Sometimes it's about the white noise, right? That sweet white noise.
That's true.
I don't know if the Dyson, I know they're pretty quiet. So.
But they're also super expensive relative to the generic electric box fan, right?
Yeah, it's hard to justify unless you say, well, it's kind of like art, to pay $250 for a fan that you could buy a fan for $15 that does the same job. You really want to it needs to have a place in your home that's like, there it is, and it cools me. Which that you can kind of justify. Like, if you're going to put some other piece of art in that same spot that was going to cost you money anyway, then maybe it makes sense.
You could take down the Picasso and put up the Dyson fan.
Exactly. Like, I spent $40 on a water... Wait, I'm blanking. What do you call it? They water your plants with? Teapot? It's not a teapot. It's not a teapot, obviously.
A water jug?
A water... What do they call those things? I don't know. A watering can. I'm an idiot. A watering can.
Okay.
But I bought a sort of artsy-looking watering can so I can leave it out all day in plain sight, and it doesn't look just like a cheap, crappy plastic one, you know? That's the same principle here with the Dyson fan.
Yeah. You can leave it out? Is that it? You can leave it out and not have to worry about it?
Well, if it's got an artistic quality, you can leave it in your space and it can hide in plain sight. Kind of, I think that's what Dyson's going for, rather than just like having an ugly, cheap fan in your big space.
Yeah.
Anyway, so Jetoptera looks pretty cool. Who knows if it ever comes to fruition. But it's an interesting concept. It's definitely one of the very outside the box ones amongst a very outside the box kind of sector with eVTOL, since they're all so different.
Oh, yeah.
And yet have a lot of similarity. This is the first one, the only one we've seen with that fluidic propulsion system. So we'll keep an eye on it. All right, well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.